mean value theorem here. All right, so there's sometimes instructors actually want you to, they want you to lay out the definition of the mean value theorem. We don't need to do any of that for this, but it's, you have to find f of b minus f of a over b minus a. That's the first part. Do you remember that from class?
Yes.
Okay, so we got to find f of 0 or f of 2 minus f of 0 over 2 minus 0. Okay, so f of 2 is 2 times 2 squared minus 3 times 2 plus 1. And then that becomes, what is that? 8 minus 6 plus 1. Looks like 3. And then f of 0 equals just 1. So something like 2 over 2, which is 1. And that's just the first part.
Okay.
The next part is you have to take the derivative of this. You need to find f prime of x. So f prime of x is 4x minus 3. And you set that equal to this number you just found. And then you solve for x.
Okay.
So x ends up equaling 1. You check that this is in the window, the number. So in this case, 0 to 2. And it is.
All right.
Now, do you need any more than this? Like, or do you just need to know the mechanics of it, or do you need to actually like understand what it is that you're doing here?
I understand what I'm doing. It's just the mechanics.
Okay. All right. Well, should we do 11?
Yes.
Okay. So again, you gotta evaluate both endpoints. F of b minus f of a over b minus a. F of 4 minus f of 1 over 4 minus 1. And by the way, this right here is the average rate of change.
Uh-huh.
You probably saw that in a previous part of the course. So f of 4 is the natural log of 4. F of 1 is the natural log of 1, which is 0. That's important. Okay, so this becomes the natural log of 4 minus 0 over 4 minus 1. And that becomes the natural log of 4 over 3.
And that's the answer.
Well, no, that's part 1. The next thing you have to do is take the derivative
derivative
of this. The derivative of this f prime of x is 1 over x. And you set this equal to natural log of 4 over 3. And now you have to solve for x.
Okay.
So you can cross multiply here, butterfly, whatever you like. 3 equals x natural log 4. So x equals 3 divided by natural log of 4.
All right. Can we do some Rolle's theorem?
Sure. That means going backwards to like numbers 1 through 4. Is that okay?
Yes, I think that. Yes.
Okay. All right. So sorry, I just need to
You're good.
review this. These never come up again. But why is this one not more clear to me? Okay, do you want us to do like number one?
Yes.
Okay.
Is it kind of the same thing you do with the mean value theorem? You just,
Well, yeah, they're used in different situations. So we need to find f of 1 and f of 3. So f of 1 is 5 minus 12 times 1 plus 3 times 1 squared. So that's 5 minus 12 plus 3, which is -4.
I guess
And
this is like deciding which one to use.
your instructors should tell you. It's not like you would ever encounter
Don't,
a
okay.
it could seem like that, but it really isn't. So
Alright.
this one is this one's also -4. Okay. So so here's the point of this one is that like let me draw a graph. So here's what we know so far about this. We know that at 1, I've drawn this really poorly. We know at 1 it's -4. And we know at 3 it's also -4. So I'm going to draw a possibility. Here's how we get to -4. Let's just say the graph does that.
Mhm.
Does this have a horizontal tangent there?
Yes.
Of course. Okay. And then let me draw another path. Let's say it does this. Does it also have a horizontal tangent?
Yes.
Okay. Now let me draw something a little bit harder here, but see how this one has one here and here.
Hmm.
So Rolle's theorem says there's at least one critical point between them. And sorry, to be clear, the critical point is that max, that min, that max, that min.
Okay.
And that's because these are the same. Okay, so like you have to check the endpoints and see that they're the same. Then you take the derivative, f prime of x, which ends up being -12 plus 6x, and you set that equal to 0.
Hmm.
And you solve for x. So you end up getting x equals 2. And this needs to be in that window, 1 to 3, and it is.
Alrighty. So what if it's not in the window?
Then it violates Rolle's theorem. It has to be. You made a mistake. I'm sorry, that's the right answer. You made a mistake if it's not.
Oh, okay. So if you do Rolle's theorem and it's not inside the interval, could you use mean value theorem? Would that change anything?
Let me try to show you geometrically the difference between the two. And that's what's kind of trying to get you to answer me on. So here's mean value theorem. Mean value theorem, I have a point and a point, and there's a slope between them, right?
Uh-huh.
Now the actual curve looks like, maybe the actual curve looks like this. Is there a tangent line that's parallel to it? Yes. Okay. Rolle's theorem, you always start out at the same place. So there's a horizontal line between them. But the curve could do really anything, but does it also have a horizontal line that's parallel? Yes.
Yes.
So Rolle's theorem here is that it's horizontal tangent lines, whereas the mean value theorem, they could be horizontal, but they're usually up and down, up and to the right or down and to the right. It's the mean value theorem is the more general case.
Mm.
Is that any better? Or do you want more examples of that?
No, you're good. I understand it.
Okay, so let's quickly do number 3 to kind of make this clear. There is a good use case for this in real life, but I mean we're not trying to do that. But That's where, if we were in a classroom, I could give that to you, but I know you're just trying to get through this work. So f of 0 is 0. F of 9 is the square root of 9 minus 1/3 of 9, ends up being 3 minus 3, which is 0. These have to be the same for Rolle's theorem to work.
What if they're not the same?
Then you made a mistake or you can't use it.
Okay.
Okay. And again, like what that means is on the graph, there's 2 points. There's a point 0, 0 and 9, 0. Okay. And we don't know what it does in between, but when you take the derivative, f prime of x, there should be a place in here from 0 to 9 that has a horizontal tangent.
Okay.
So the derivative here is 1/2 square root of x minus 1/3 equals 0. So you take your derivative and you set it, equal to 0. And this is where you got to, be really solid with your algebra. So you get 1/2 square root x equals 1/3. Again, you can kind of butterfly here, cross multiply. 2 square root x equals 3. Divide both sides by 2. And then you square both sides. So x equals 9/4. And is that from 0 to 9? Yes.
Okay. I saw something about him saying finding the critical numbers.
So the critical numbers are when the derivative equals 0.
Oh, so you just found the critical number, right? 9/4 is critical.
Yes.
Oh, okay.
When f prime of x equals 0.
So if you were just told to find the critical numbers, you would
Take the derivative, set it
take
equal to
derivative,
0.
set it equal.
And that's like in a, let's see what problem where you start doing that.
I think I see you saw.
Yeah, 23 is where that starts. Any of those problems we could look at if you want to look at critical numbers.
Okay. Yeah, let's do that.
All right. Do you want us to do 23, 24? Do you care?
It doesn't matter to me.
Okay. The reason I asked, I'll just reiterate this, is like the odd ones you probably have in the back of the book.
Yes.
So I'm happy to do the even ones so that you,
Okay, that works.
you tell me.
That makes more sense.
So let me snip in the even ones.
24 looks like something he would put on a quiz too.
Okay. Let's take a look here. All right. So finding critical numbers, you have to take the derivative. 3x squared plus 12x minus 15. You have to set it equal to 0. So here you're going to have to factor. So you try and factor out of 3. And then you factor this, x minus 5. I'm sorry, plus 5, x minus 1. So you get 2 critical numbers, x equals 1, x equals 9 minus 5. These are your critical numbers.
And if you were given an interval in the problem,
yes,
you would just cross out the one that is in that interval.
Right. Now you could have more than one in an interval though, too.
Right.
So that's a possibility, but yes, exactly.
Okay.
That's it. Okay. So then like we get to the more, interesting problems. So I guess only the odds are shown here. So do you want me to go to like,
Can we do number 29?
Yes. So 29 is reinforcing your quotient rule. G prime of y equals, okay, so it's bottom times derivative of the top. Derivative of the top is 1 minus the top times the derivative of the bottom, which is 2y minus 1, all over the bottom squared. Okay. All right, now, normally you don't do anything with the numerator. Like in the previous test, it was like, just leave it. But because you need to do something, you want to simplify it. Okay. So, and the bottom's irrelevant now, so I can actually just look at the top, but I will, keep having it there. So this I'm gonna have to FOIL. It's 2y squared minus y minus 2y. That's minus 3y plus 1. And then we're going to combine like terms in the numerator. So it's y squared minus 2y squared. So that's minus y squared minus y minus a minus 3y. So that's plus 2y. 1 minus 1 is 0. So that's nice. And then you can write the bottom again. Like that's great. So this is where you have to remember when you have a rational function like this is rational. When does it equal 0? It equals 0 when the numerator equals 0. So you just set the top equal to 0.
Okay. So you don't even need to worry about the bottom.
Right, and that's why I said you don't worry about the bottom, don't worry about the bottom, but you keep writing it if you want, but you don't need to. So you can factor a y out. Minus y plus 2 equals 0. So either y equals 0 or y equals -2.
Okay. All right. Can we do number 35 next?
Yes. This is a product rule question. So this is why, you thought, oh, and maybe you thought in the last chapter, oh man, taking derivatives is tough, or, maybe you got the hang of it, but now it's like expected that you can do the derivative.
Mhm.
So you gotta be really solid with your derivatives.
I gotta get more comfortable with E.
Yeah, so
Every time I see it, it just kind of weirds me out.
yeah, it's a good one here because it just is itself when it's the derivative times the chain rule. So I think we said u v prime minus vu prime.
Yep.
So uv prime is x squared. The derivative of e to the minus 3x is itself. Then you look at the exponent here. What's the derivative of minus 3x?
-3.
Minus 3. That's a plus. Plus e to the minus 3x. What's the derivative of x squared?
2x.
2x. Okay. All right. Now, what is common to both? Because you're going to set this.
The
This is,
-3x.
yeah, that's there. E to the -3x. There's a bit more, but I'll rewrite it. Minus 3x squared plus 2x equals 0. Okay. Anything else common?
An x in there.
It's an x, yeah. So it's x e to the minus 3x times the quantity minus 3x plus 2 equals 0. So now you set each of these equal to 0. X e to the minus 3x equals 0 and minus 3x plus 2 equals 0. And you get 2 points. Actually, I don't need the parentheses on this one over here. So x is 0, because that's the only way this is 0 is when that's 0, and then x equals 2/3.
Why does that equal 0?
On the left.
Yeah.
So e never equals 0. This is
Uh-huh.
never equal to 0. If you look at a graph of e to the x, it's either like that. If it's negative, it's like that. If it's flipped, it's like that. It's never, I mean, it's hard to believe, but it's never equal to 0.
Uh-huh.
But x is, right? If x is 0, 0 times anything is 0.
All right.
If you don't like that, don't factor the x out because it'll come in here. Like we're to look at just this part, this minus 3x squared plus 2x. Maybe that's more clear. Minus 3x squared plus 2x equals 0. You would factor an x out and get minus 3x plus 2 equals 0. And then you would set each of those equal to 0. X equals 0, minus 3x plus 2 equal to 0.
Okay.
And that's it. I mean, that gives you the same two values. You have that this is x equals 2/3. The other one is x equals 0.
Okay. Alrighty.
Okay, what do you want us to look at next?
Let me see. Number 49. I think I sent it to you.
Okay, well, what are the instructions for this one say?
It's I think it's find the absolute maximum and minimum. I'm pretty sure. Let me just double check for you.
Yeah, that sounds right.
Yeah.
All right, so to do
Yeah.
this, you have to evaluate the two endpoints first, f of -1 and f of 1. You always evaluate the endpoints. And they will give you them. Sometimes they give you like, they'll say like 0 to infinity, and then you can only evaluate it at one place. But you evaluate it if at all possible. So that's natural log -1 squared plus -1 plus 1. This ends up being natural log of 1, which is 0. And then this one is a natural log of 1 squared plus 1 plus 1. That's the natural log of 3, which is the natural log of 3. Okay. All right, so then that's kind of the first part. The next part is to take a derivative. So your derivative is 1 over the inside function. So 1 over x squared plus x plus 1 times the derivative of the inside function. That's the chain rule part. So the derivative of x squared plus x plus 1 is 2x plus 1. Is that okay?
Yeah.
So we got 2x plus 1 over x squared plus x plus 1. And you have to set this equal to 0. You're like, okay, we just talked about this. Whenever it's rational, you set the numerator equal to 0.
Mm-hmm.
Where is the numerator equal to 0? So set 2x plus 1 equal to 0, x equals -1/2.
All right. That's the answer right there.
Well, that is that no. So that's your critical point. That's your critical number.
Okay.
Okay. So your critical number is -1/2. Is that in between these two numbers?
Yes. Right.
Is it between those two numbers? Is it between -1 and 1?
I think so.
Yes. Yes.
Okay.
So then and you have to come back up here and you have to evaluate it at -1/2.
Okay.
So it's natural log of -1/2 squared plus -1/2 plus 1. This one's nasty. This one's bad. So it's natural log of 1/4 -1/2 plus 1. So it ends up being the natural log of 3/4. Yeah, 3/4. Okay, so now you have three different numbers. You have 0, natural log of 3, natural log of 3/4.
Uh-huh.
Okay, and the you have to figure out which is the smallest and which one's the biggest. So natural log of 3 is the largest. This is the max. But now it comes down to, well, where's natural log of 3/4? So if you look at a graph of natural log of x, at 1 it's 0, 1 comma 0. So the natural log of 3/4 is right there somewhere. So it's going to be smaller than 0.
Okay.
This is your min. Usually it's a little bit more straightforward. Like it's like 216 versus -45, but here it's not, it's Are you allowed to use a graphing calculator on this exam? Or in general on this class?
Say it again.
Are you allowed to use a graphing calculator?
No calculator
Okay.
at all.
All right. Yeah, there's a shortcut there with calculators to kind of visualize this, but so again, the recipe, I'm big into these recipes. The recipes are you have to evaluate the endpoints, which we did. That's pre-calculus stuff. Then you have to take the derivative, which you did. That's your calculus stuff. Then you have to set your derivative equal to 0. You did that. Find the critical number. That critical number you have to evaluate back in the original. Now you might have two critical numbers. If you have two critical numbers, you got to evaluate them both. Are there any before 49, like 47, 48 that are worth doing? Or if not, I guess we can go back and do some curve sketching, maybe.
Oh, I got yeah, the problems were the 7, 8, 9, 10 ones where it says sketch a graph. Yeah, I'll take a look at those.
Okay. I'll just do the evens. Unless maybe your backup book says there are many possible solutions. These. All right, a graph has an absolute minimum at 1. These are x values. Absolute max at 5. Local max at 2. Local minimum at 4. All right, so let's draw. You want to get some coordinate, some axes going here. See if we can do this. So absolute minimum at 1. So it doesn't necessarily need to be like way below, but for at 1, but I'm gonna say that's your absolute minimum. And then an absolute maximum at 5. So 1, 2, 3, 4, 5. So I'll just do something up here like that. Local maximum at 2, local minimum at 4. So at 2, it has to be less than this one by some amount. So I'll just draw one like right here. So and these are, this is to indicate it's a max, and this is a max, and this is a min. And there's a min at 4. Now it can't be this low. So there's lots of options, as I mentioned. And I think you'll see it here when I do this. Yeah, and I just start connecting them. Okay, and now it's like, well, what do I do from here? Well, because this is your max, this thing's got to like come back to the right, and maybe this one has to come back to the left, something like that. That's one possibility. There's actually a ton. Ton of options here. Okay, cool. Should we look at 10 now?
Yep.
All right, so there's so much going on here. It says that it has no local max or min, but 2 and 4 are critical numbers. Okay, so what could that mean? So there's 3 types of horizontal tangents. Let's just cover that first. Horizontal tangents that you could have. One is a max, the second is a min, and the third is neither. And that's what we're looking for here. So there's your max, there's your min, and here's your neither. It's that, or it's that. Like I didn't draw it great, but there's kind of a horizontal tangent right there, but it just keeps going. Is that okay?
Yes.
All right. So it has no local max, but 2 and 4 are critical numbers. So the graph here that I'm thinking of is that at 2, it's got kind of that like right there, and at 4, it's got something like that. So it's like up, and maybe it goes down. It could, let me draw one in red here that would also work. I'll just have to add this one down here. It could be that you have something like that, like that.
Uh-huh. Okay.
There's lots of possibilities. Where should we go from here?
Let's see which ones I need. Did we do number 12 for the
take a
mean
look.
value theorem?
We did 12 is 12 some sort of a, oh no, we can do number 12. Let's do it.
Okay.
All right, so for the mean value theorem, I mean, so that's what I was kind of asking, like in class, there's these definitions, like, okay, it's continuous on an open interval, it's
Yeah.
differentiable, or it's you can look that up. I mean, that's not really important, but sometimes they do want you to write that down when you're on a test. So you may need that. Here again, you have to do f of b minus f of a over b minus a. This is your a, this is your b. So it's f of 3 minus f of 1 over 3 minus 1. So let's figure those out. F of 3 is 1/3. F of 1 is 1 over 1. So we can substitute those in. 1/3 minus 1 over 3 minus 1.
Okay.
The numerator is minus 2/3. The denominator is over 2. So you can multiply the top and bottom by like 1/2, and you end up getting a negative 1/3. But that's only like part 1.
Mhm.
The next thing you have to do is take a derivative. Like you're in calculus, you've done derivatives, you got to know how to do derivatives now. And the derivative of 1 over x is minus 1 over x squared. And you set that equal to this number here.
Okay.
So from here, there's no more calculus, but there is, manipulation to be had. So you get it's really 1 over x squared equals 1/3. Again, you can butterfly, 3 equals x squared. X equals plus or minus the square root of 3. Are these both in the interval from 1 to 3? And the answer is no. It's only square root of 3. Negative square root of 3 is not in that interval.
Mhm.
Here's 1 to 3 on your number line. There's the square root of 3. There's negative square root of 3. So it's no good. So that's why you can't just say, oh, I got it, I'm done. You have to look and see, is it actually in the interval?
Uh-huh. So with mean value theorem, you don't set it equal to 0.
No, that is the main
That's
difference.
the big difference. Okay.
Yeah.
Okay. That'll help a lot. Honestly, I thought I had more like problems and stuff to go over.
It's up to you if we end here. You're the customer, so
We can cut it short, to be honest.
okay. Well, I appreciate you booking and hope you got some good help out of this tonight. And
Yep, I did.
I'll see you next time.
Did you, is there any way you could send all these notes by tonight?
I'll send you the notes right now. I'll
Okay,
reply to the booking email. The video, it's the video that takes the longest to
yeah,
finish and all that. So,
yeah.
yeah,
Don't
I'll
worry about
send
the
it.
video. I just would like the notes.
Absolutely, I'll send it right now.
Alrighty, cool. Thank you.
All right, thank you. Bye now.
Bye.